everyone, and welcome to our special session on game changer technologies, where we'll be introducing you to some of the most cutting-edge technologies that will help to transform gas and electricity networks in this country for the coming years and decades. For those of you who don't already know me, I'm Randolph Brazier, Head of Innovation at the ENA. In our tech showcase, we will be hearing succinct 5-minute presentations on new technologies from a mix of innovators. Some that are already newly emerging in the UK after having disrupted energy systems in other parts of the world. Some that are already known to us but are bringing out new innovations that we haven't heard about and are yet to discover. And others that are startups in the true sense of the word. I very much look forward to hearing about these innovations and to learning more about the benefits they might bring to our members and networks at ENA. Don't forget that if you have any questions for our presenters, please ask them in our text-based Q&A facility to the right side of your screen throughout the session. I very much hope that you enjoy the presentations.
If you're in charge of substation or distribution reliability for an electric power utility, distribution system faults can be a major concern. They cause outages, equipment damage, and increased regulatory pressure, which all hurt your bottom line. If we say that 80% of faults on overhead lines are temporary, utilities have traditionally relied on reclosers to clear faults and prevent sustained outages. The problem is, reclosing contributes to overall system reliability issues by putting the full force of the fault back on the distribution system up to 4 times. With this fault multiplier effect, reclosing takes a small problem and can turn it into an even bigger, more expensive problem. This can cause a great deal of damage to distribution equipment, such as cable joints or jumpers, and over time, it also wears down substation transformers, subjecting windings to hundreds of thousands of pounds of unnecessary mechanical forces that look like this. It's time for a better way. S&C's IntelliRuptor Pulse Closer Fault Interrupter uses a unique innovation called pulse closing technology. Pulse closing technology uses a small pulse of current to detect the presence of a fault. This results in less than 5% of the energy to test for the presence of a fault compared to reclosing. Pulse closing technology detects the presence of a fault, but without the harmful fault multiplier effect, resulting in better reliability. Here's an example of a recloser closing on a fault with full force on the overhead distribution system. As you can see, the damage of reclosing with full force can be drastic. The more we stress our utility system, the shorter the life of its components and the shorter the life of the system altogether. Now demonstrated here is the IntelliRuptor using pulse closing technology to test the line for faults. It's clear to see how much smaller strain is put on the distribution system using this truly unique and innovative technology. Thanks to surveillance footage, we've got footage of a real-life situation which shows a recloser working upstream on a fault. After the third attempt of reclosing, a fire breaks out within the substation, causing a lot of damage. Issues like this happen not only in substations, but they happen in the same way on a distribution feeder. The substation reaps the benefits of pulse closing technology with just a tiny fraction of the mechanical force being put on its windings. The IntelliRuptor is the first breakthrough in fault testing technology since the invention of reclosing. It is truly a substation transformer life extender and a lifesaver for distribution system equipment, improving your bottom line. To find out more about the Inteliruptor, come and speak to us in our S&C booth, where we can further explain the benefits of this innovative technology and discuss a possible trial of the Inteliruptor on your distribution network.
Hello and welcome to this Calvatech Presense Tech Showcase, our LV monitoring solution for a modern energy system. I'm Samir Alalat, responsible for innovation and business development.
And I'm Jim McRae, the product manager for the Presense monitor.
Now a little bit about the wider company. Calvatech is part of the Camlin group of companies. The two other major parts of the group are Camlin Power, whose main focus is on providing products which monitor and capture the performance of transformers and of switchgear, and Camlin Rail, who provide products to the railway industry which keep the trains running. Calvatech has one simple aim in life: to make sure that your networks run as well as possible, as cost efficiently as possible. So, what is Presense? Presense is an edge computing enabled LV monitoring device that provides distributed intelligence and data capture. Installed at substations and other supply points on the network, Presense uses intelligent and dynamic trigger mechanisms to capture power flow data. These intelligent trigger mechanisms capture high-frequency, high-resolution datasets which identify development problems on the network, along with the location of both identified faults and pre-fault activity. This ultimately enables proactive management of the network. Its edge computing capabilities make use of artificial intelligence algorithms and a machine learning decision engine. Presense only communicates information that's relevant to the use case of interest, minimizing data transport, storage, and management costs. We've developed these capabilities based on the huge amount of experience we have in collecting data from connected devices and utilizing the vast amount of fault and power quality data we've collected for over a decade. At the last count, we had collected over 1 million fault bursts from LV networks, a further 20 million bursts from our custom-built test center, and we've collected approximately 20 million hours worth of load data. I'm going to hand over to Jim now to talk about some of the specific capabilities of Presense. Jim?
Thanks, Samir. So what were the guiding principles with our design? We'll touch on 3 key areas for any monitoring device, areas that if you get right, will ensure that you can maximise the potential benefits for employing LV monitors. The first is the Class S power measurement capability. If you cast your eyes over the slide, this allows us to collect high-resolution data in a number of areas, to a quality that's not normally associated with a product of this type. We're confident in the knowledge that the data is going to be good enough to fulfill a number of complex data use cases, such as predictive fault or phase balance interventions, and know that as new use cases develop, we have the quality and granularity of data that we need. The second is the capability to perform fault location. This for us is an essential part of LV monitoring, allowing you to deploy them and stack benefits to consumers, along with operational savings and enhancing network planning. Our patented self and MELF algorithms are installed on the device. The third is the compact design and flexible sensor types to allow it to fit into tight spaces and be as interoperable as possible with the many different network environments that it may encounter. Sam, do you want to go through the benefits that the Presense can enable?
Thanks, Jim. Presense can deliver big benefits, giving visibility of the LV network at a time of unprecedented change for the industry. It will enable predictive fault capability, allowing you to identify, locate, and repair faults before they have a customer impact and thus a business impact. The quality of the design, targeting strategies, and the measurement capability allow for stacking of incentives and customer benefits, allowing you to make a cost-efficient business case. The power quality data Presense collects will enable numerous network and cable health data use cases, such as informing phase balance, meshing, and fault management interventions, as well as allowing you to plan for proactive cable overlay and repair, all the while ensuring reductions in customer interruptions and customer minutes lost. Presense is an open and interoperable LV monitoring solution. It's been purposefully designed with the open data transformation that the industry is going through in mind. The data that it collects can be passed directly to the DNO before being disseminated out to third parties, can work as part of a multi-vendor DNO deployment strategy or standalone, and user-owned triggers can be deployed to run alongside our own proprietary triggers. That draws our Presense Tech Showcase to a close. Thanks for listening, and if you need any further information, don't hesitate to check out the Calvatech stand or contact your account director. Thanks again.
Hello, and thank you for allowing us to talk about Schweitzer Engineering Laboratories at the Energy Networks Innovation Conference. SEL has always been about innovation. Our company was founded by Dr. Edmund Schweitzer III, who invented and began development on the first microprocessor relay in 1982. It was released in 1984, and since that initial release, we continue to improve critical control systems, making them safer, more reliable, and more economical. In order to keep up with power moving at the speed of light, traditional Ethernet networks that may work really well in a corporate environment do not have the determinism, speed, and security required in critical control systems. In October 2016, Schweitzer Engineering redefined Ethernet for critical control systems with operational technology software-defined networking.
It's a very exciting time to be a network engineer because we're challenging what the status quo expectations are. We're redefining what performance possibilities are and giving that control back to the engineer.
So software-defined networking is a revolutionary approach to solving the inherent limitations of Ethernet. Ethernet was never designed with real-time operational system requirements in mind. It was designed for plug-and-play, convenience and ease of use with a trusted user model. And those issues prevent it from being a good solution for real-time operational network systems. With software-defined networking, we saw 4 key attributes that it provided that allowed us to deal with the inherent limitations of traditional Ethernet. The first one being much faster failover times.
My heal times now move from milliseconds with spanning tree down to microseconds for any link failure or any switch failure, regardless of the topology that your network is. Most applications won't even know that you had an event. The network heals so fast.
Simplified network design and testing. That's a huge deal when you're designing complex systems.
So you are no longer managing switch by switch. You're managing your entire fleet of network appliances as a single asset. The testing verification then also gives you more confidence that what you have deployed and configured in your network is going to do what it is supposed to do in the primary and in any network failure event condition.
Software-defined networking provides a huge benefit in terms of network security through a deny by default architecture. Deny by default means we define as the designer exactly what packet, what application is allowed to use the network. If the application or data packet doesn't meet a predefined set of rules, we will by default deny access to the network for that piece of data. And it's that attribute that makes SDN networking far more secure than traditional Ethernet. And the final attribute is centralized network visibility and diagnostics.
So after your network is configured and operational, now you have a near real-time view of what's happening on your network. At any given time, you can see exactly what applications are on your network, where they are, what paths they are, and how much data is transferring across there.
SEL's SDN solution utilizes a 3-layer architecture. Layer 1 is the hardened substation switches. We've got 2 devices, the 20-port rack-mounted 2740S and the 12-port DIN rail or surface-mounted SEL 2742S. Layer 2 is a flow controller, the SEL 5056, which enables flexible configuration of each communication flow path and the ability to proactively engineer fault-tolerant networks. The third layer is the application suite. These are the software applications that integrate with the SEL 5056 software-defined network flow controller to add capabilities to the SEL SDN solution.
No more compromises. You now have the speed, the control, the visibility, and the cybersecurity you need to have the safest, most reliable network that you can build.
We really believe you can engineer your best network, and it starts with SDN.
Please contact us to find out more about OT-SDN and many other technologies that can significantly increase the reliability and security of your critical control systems. Working with you, I want to increase your system's overall usability and performance while decreasing overall risk. Thank you for your time.
Good morning, everybody. My name is Hisham Amara. I'm the VP of Strategic Growth at Opus One Solutions. Thank you for giving me the time today to speak to you about our company. Opus One Solutions is a software and services company supporting utilities through the transformation from DNO to DSO. We help DSOs understand the impact DERs and regulatory changes have on their planning, operation, and business model. This includes supporting them in the creation of end-to-end flexibility markets. We have offices in Toronto, New York, Boston, and recently we opened an office in Glasgow in the United Kingdom. Opus One has been operating in Europe for the last 2 years. The slide highlights some key projects from within our portfolio in Europe. I would like to draw your attention to our current engagement with Scottish Power and Scottish and Southern in helping them deploy an end-to-end flexibility markets in both the fusion and transition project respectively. In addition, we're helping SSCN, Energy, and EDP with flexibility long-term and short-term planning, as well as the creation and evaluation mechanisms for flexibility, allowing them to turn these capabilities into business as usual. GridOS, Grid Operating System, is an enterprise-level software. At its core, GridOS provides full visibility across the utilities network through three-phased unbalanced modeling of the DSO's network. In addition, GridOS is powered by a four-quadrant optimization engine, which allows for the optimization of real and reactive power in all timeframes. GridOS has a modular architecture, allowing us to deploy specific capabilities to meet the DSO's needs. In addition, GridOS is SIM compliant, thus allowing for a seamless integration across the utilities ecosystem, irrespective of the system we're integrating with. GridOS has three key applications: integrated distribution planning, which is a techno-economic planning capability that can plan for every single minute for up to 10 years. DER management, or active network management, which is an operational capability that facilitates monitoring and control of controllable assets in the field using 5 to 6 different control strategies. And last but not least, flexibility markets, which is the end-to-end capability of providing flexibility markets to DSOs, starting from determining system needs and the value of the services, the creation of the market itself, the animation of the services, optimizing the bids and offers, and settling the market. I would like to end with this slide, which focuses on our 6 key offerings that are relevant to DSOs within Europe. The first one is flexibility, which we spoke about earlier, active network management, the automation of interconnections, the digitalization and process automation across planning and operations, EV planning, which focuses not only on the EV chargers themselves, but also accounting for consumer behavior. And last but not least, the ability to deploy our analytical engine as a stateless engine to seamlessly integrate with any operational system, be it an ADMS, GERMS, or GIS, which is currently under deployment within the United States. I would like to thank you for your time. You can reach me at my email address below or my phone number. Looking forward to hearing from you in our discussion later on.
Hi, I'm Jonathan Rogers from Calvatech, and in this short tech showcase I'd like to show you how Calvatech have used the learning from the Sentinel NIA project in a new solution for 11 kV overhead networks called LineSight. LineSight is a monitoring solution for overhead lines that can help with finding damage in real time, such as faults, downed lines, low-hanging conductors, and it will also help mitigate against CIs, CMLs and reputational damage. It's possible to see the intermittent problems developing on a network, as well as providing information on the condition. For example, it'll help with health assessment programs. It's also possible to see damage to insulators and damage caused by arcing. A key benefit of LineSight is to locate faults to within a few spans, and to do this fast, as well as detecting and locating developing network issues before they become outages. With accurate location information, it is possible to allocate the correct resource to incidents during storms. And with continuous monitoring, even when the network is dead, that means that you can quickly identify and locate nested faults during storms rather than detect them once the first faults are repaired. LineSight will also help you to target maintenance, upgrade and replacement budgets to get maximum benefit. Tailored reports allow you to see how LineSight is improving reliability and safety of the network. Things that help from an operations perspective: where is the fault? What team do I need to send? How quickly can I get it repaired? Is there a second fault? What type of damage is it? Do I need, what materials do I need? Do I need insulators, conductors, that type of thing? It's also useful to find out how is the network performing. Is it safe to put a line back in after protection trips? Is the network safe to operate? And is the network getting to the limit of its operations? LineSight works with APRS schemes to help restore power even quicker after a fault. So from an asset perspective, we can see what is the condition of the network. Are there incidents on the network that are a repeat thing? Is it always going to be faulting? And therefore, do I need to do something different? Maybe an intervention or a refurbishment. LineSight is installed at typically 5 or 6 poles on an 11 kV overhead distribution circuit. It consists of a measurement crossarm, a VT power supply and monitoring cabinet. By continuously monitoring the network, LineSight will detect and locate any abnormal conditions such as interference from growing vegetation, insulators that are breaking down, and any major damage that occurs too, such as trees falling into lines. With a location accuracy of 500 meters, knowing where to send a repair team reduces the need to send scouting teams to walk the line first. LineSight results can inform automated power restoration schemes to help restore power fast. During storm outages, LineSight continues to monitor and detects the occurrence and location of nested faults, enabling repairs earlier. LineSight can detect lowered lines too, keeping control room operators informed. LineSight also allows better decisions about intervention and network refurbishment. Information from LineSight available in the control room helps control engineers to make the best decisions. With knowledge about how the network is performing, is it safe to operate or put a line back in? And is the network nearing the limits of its operation? To enable a progressive transition and for easy adoption of LineSight, we're currently talking to DNOs about a guided business as usual adoption program. This program will help assess the benefits LineSight will bring you by using data analytics to build a robust business case that can maximize network performance and reduce the costs of ownership of the network. As part of this program, a small-scale technology demonstration is proposed that will output the policy and working practices for your network, as well as integration into the NMS and control center. We are currently meeting with the distribution network operators and with a timeline to start data analysis and business case development in quarters 1 and 2 of 2021. I hope you've enjoyed this tech showcase for the 2020 ENIC conference. If you're interested in LineSight and would like more information, please visit the Calvatech stand in the main foyer of the conference, where you can talk to one of our Calvatech representatives and pick up a copy of the LineSight overview brochure.
Well, thank you very much to all our Game Changer presenters. That was awesome. That for me was a real eye-opener, I'm not sure about others, to learn about how these new technologies will contribute towards the transition to our future energy system. I personally want to find out a bit more, and if you do too, if you want to find out more details about the solutions or speak to some of the presenters, please do visit them at the stands inside the exhibition and innovation halls, where they'll be waiting for your questions. In these virtual halls, you'll not only be able to join them and chat, but you'll also be able to engage in a video call if you really want to get into a bit more depth, go into a bit more detail with the innovators that we just heard from. Thank you very much for coming along and participating in the Tech Showcase session. I really hope you enjoyed it as much as I did and look forward to seeing you in the halls.